Dear children, in this video I am going to discuss about equation of a line. If you want to get a line uniquely in the space, what are the different possibilities? Suppose we have a line passing through one point. So is it uniquely determined? How many lines will be there passing through a point? So there are infinitely many lines passing through a point. So that information is not complete to get a unique line. If I say a line parallel to a given vector, can you find a unique line parallel to a given vector? No, that is also not uniquely determined. There can be infinite number of lines which are parallel to a given vector. But if we combine the two conditions, okay, a point is given and a vector is given. So how many lines will be there passing through the point and parallel to the given vector? Then definitely there will be one and only one line passing through the point and parallel to the given vector. Then what will be the equation of this line in general? That is what we are going to discuss first. Suppose we have a line and the line passes through a point whose position vector is vector A, and also the line is parallel to a vector, the vector is B. So we have to express a universal relation, a general relation which is always true involving A and B. That is our task. For that, generally what we do is we take a general point on this line. A general point means the point can be anywhere. Suppose P is a point on the line whose position vector is vector R. There will be always some origin. Okay, suppose this is the origin. So position vector of the point, given point is small a. Position vector of the general point P, that is R. So we have to connect a relation between the vector R, vector A and vector B. So how it is possible? So let us consider the vector from A to P. Then we know that vector AP and vector B are always parallel. So if two vectors are parallel, a collinear, then one vector is a scalar multiple of the other. So here what we will get is the vector AP always equal to some scalar into vector B. Whatever the position of P, wherever it may be, the P, wherever it may be on the line, given line, then this relation is always true. Vector AP is always equal to lambda into vector B. Now what is vector B? In terms of position vector, it is OP minus OA. Vector OP means R vector, vector OA means A vector. So R minus A equal to lambda into B vector. Or this can be modified into R vector is equal to A vector plus lambda times B vector. So this relation is the equation of the line in the vector form. Now we will discuss the equation of the line, the same equation in the Cartesian form. Cartesian form means the coordinates will be given. So the line passes through a point whose coordinates will be some x1, y1, z1, and the line is parallel to a vector. That vector can be taken as ai plus bj plus ck. Okay, then the general point, the position vector of the general point will be always equal to some x I, sorry, we have to take the only the point, the coordinate of the general point, capital P, always x, y, z. Now we apply all these terms in the vector equation. Remember, the vector equation is r equal to a plus lambda b. Vector r equal to the vector equation reduces to r vector means x I cap plus y j cap plus z k cap. R vector is equal to A. A vector means x1 I cap plus y1 j cap plus z1 k cap plus lambda times AI plus bj plus ck. So if you remove the vector part from both sides, you compare the corresponding components, similar components on both sides, what we will get, x minus x1 equal to a lambda, y minus y1 equal to b lambda, z minus z1 equal to c lambda. So if we eliminate lambda from all these equations, what we will get is x minus x1 by a is equal to y minus y1 by b equal to z minus z1 by c. So this will represent the Cartesian equation of the line passing through the point x1, y1, z1 and parallel to a vector whose direction ratios are a, b, c.